So we have Liana. You're Liana. And then Liao. Oh, it's you. Are you connected, Angela?
Yeah, I'm still Jeffrey.
Oh, you're Jeffrey. I was like, who is Jeffrey? Okay. Okay, so you all see my notes, the screen? Okay, so the domain of a function is the set of x values for which f of x is defined, okay? For many functions, like a polynomial, so if you have like f of x equal to x squared or x cubed or x to any power n, which n is greater than 0, an integer, positive integer, then there is no restriction on x. So if you have a positive power of x, like x squared, x to the power 3, x to the power n for some positive integer, then there is no restriction on x. That means the domain of any of the above functions, for each of them, the domain is just all real numbers.
Is that an I and R?
Yeah, it's a R with an extra line beside it. So the domain for any positive power of x is just a set of real numbers, because there is no restriction. You can have x, any number, positive, negative, anything. How about, but there can be some restrictions if you have a denominator. So another example. So if you have a denominator like f of x equal to 1 over x. So here there is a restriction on x. There is, yes. You ask a question? Oh, sorry. There is a restriction on x. And what is the restriction here? X can be 0. So x must be non-zero. So that means the domain of f here is the set of all real numbers except 0. What if you have like f of x equal to 1 over x plus 2 or 1 over x minus 3? Exactly the same logic. So the only restriction is x cannot be equal to -2. So the domain would be all real numbers except -2. Okay, so that means if you have a denominator, if you have in general, if you have a fraction, like a rational function, we call this type of functions rational functions. If you have a rational function, so the only restriction is that the denominator in general, the denominator for rational function cannot be 0. But you can have more complex denominator. For example, another example, what if f of x equal to 1 over x squared minus 5x plus 6? So that means if you have a denominator, you have to find its zeros and then exclude the zeros of the denominator from the domain, right? So given a rational function, you look at the denominator and then you find the zeros and then you exclude the zeros. So what are the zeros of the denominator? So zeros of denominator. That means at what values of x the denominator is 0? So x squared minus 5x plus 6 equal to 0. 2 and 3. Once you find them, you have to exclude them from the domain. So that means x squared minus 5x plus 6, yes, as you said, is x minus 2 times x plus 3. So that means there are 2 zeros, x equal to 2, x equal to 3, and then you exclude them from the domain. That means, yes.
X minus 2, x minus 3.
Oh, sorry, yes. That's right. So now the restriction on x is, what are the restrictions? So we have 2 restrictions. One is x cannot be 2, and one x cannot be 3. You see, I'm excluding the zeros of the denominator from the domain. So now I can say that the domain of f is all real numbers except 2 and 3.
We have to include the pregnant outside the R, like that line thing. We have to include that.
So the meaning of this means the set of all real numbers x in R such that x is not equal to 2, x is not equal to 3. So here it means basically all real numbers except 2 and 3. And if you want to show this in terms of intervals, union of intervals of numbers, you can say this is the same as, or let me first tell you that, so look at the example on the top, f of x equal to x plus 2. Look at that example. So the domain is everything but -2. If you want to show this in terms of the union of intervals, so you have all numbers except 2. So that means the domain, you can also say that the domain is equal to -infinity to 2, sorry, -2, union with -2 to infinity. Because we have open interval, it doesn't include -2. Okay. So, and here you have to exclude 2 and 3. So you have -infinity to 2, union 2 and 3, union 3 and positive infinity.
We have to do that on the test, just the union version and the domain version.
No, you don't have to, but I mean, you should know this.
We should?
Yes.
We didn't know that, no?
No, I'm teaching you.
Oh,
Okay. I mean, this is not a deep thing. It's not complicated. Don't worry. I mean, if you have problem, you can come and I will explain to you in more details. Okay. Okay. So for denominators, remember, for denominators, there is restrictions, and the restriction is that the denominator basically cannot be 0. That's the only restriction we have. So Now, what if you have a square root? So that's another type of restrictions for functions. So for a square root, so the restriction is that x must be greater than or equal to 0. X can't be negative, exactly. Yeah, maybe I just write restriction is that x cannot be negative. So that means x must be greater than or equal to 0. So for a square root of x, the domain of f is just the set of all real numbers such that x is greater than or equal to 0. In terms of the interval notation, the domain of f is the interval, closed interval 0 to infinity. So when I put this like close, we call this close bracket. That means it includes, it's inclusive. It includes 0. But if you have an open bracket like this page, at the bottom of this page, that means it doesn't include like 2, 3, and so.
So the including one is the square bracket one.
The inclusive is the square. The other one is like the curvy. Okay. So far we have learned 2 restrictions. One is for denominators, another one for square root, but you can combine these restrictions basically. And that could be sometimes complex. So another example for square root. You see, yesterday we discussed inequalities. Now you see in action why we learned inequality. This is an application. So example, find the domain of f of x, for example, equal to square root of x squared minus 5x plus 6. So what is the restriction for the square root? Inside the square root must be positive. So the restriction is that x squared minus 5x plus 6 must be greater than or equal to 0. Now here you have a quadratic inequality, as we discussed yesterday. So you need to be able to solve this type of inequalities. So remember, for solving inequalities, we usually what we do is trying to factor if there is any factor. So x squared minus 5x plus 6. Here it's easy to factor because this is just x minus 3 times x minus 2. So I can make a chart. We have 2 zeros, one is 2, another is 3. And I have x squared minus 5x plus 6. So at x equal to 2 and x equal to 3, it's 0. Between the two roots, it's negative. Other than that, it's positive. And the reason is because the coefficient of x squared is positive. So the sign of x squared minus 5x plus 6 is positive, negative, positive. If you want to understand it clearly, this is the picture you should have in your mind. Let me draw a picture. This is basically the geometry of this algebraic equation. So you see this, or so the graph of x squared minus 5x plus 6 is something like this. You agree? Now you see in this region, it's positive. In this region, it is negative, right? Because it's below the x-axis. And this region also positive. So when a graph is below the x-axis, it's negative. When it's above the x-axis, it's positive. Now, what is the domain? So put this together. The domain, remember, you have to solve what is the restriction. The restriction is x squared plus 5x plus minus 5x plus 6 must be greater than or equal to 0. So that means you are looking for this region and this region, right? So the answer is x must be either less than or equal to 2 or x greater than or equal to 3. So that means the domain of f is all real numbers, so that either x is less than -2 or x greater than 3. So in terms of the union of intervals, it's basically equal to -∞ to -2 inclusive union with, oh, sorry, is it? Sorry, it's not -2, it's 2. It's 2, it's not negative. Okay. So it's -∞ to 2 inclusive, and then from 3 again inclusive to infinity. Okay. Now let us discuss something a little bit more complex. Let's say f of x is a square root of x minus 1 over x. So again, the restriction is x minus 1 over x must be greater than or equal to 0. There is another restriction, or maybe I just wrote that first. What is the other restriction here? You can see. No, here you see there is a denominator. X cannot be 0. So the first restriction, there are two restrictions. One is x cannot be 0. There is another restriction, which is about the square root, and that is x minus 1 over x must be greater than or equal to 0. So the first restriction is clear. You don't need to work on it. But the second restriction, you have to find the values of x that satisfy this inequality. So for the second restriction, you have to solve an inequality. How we do that? So remember, this is x minus 1 over x is x squared minus 1 over x, right? So this must be greater than or equal to 0. So Again, you can make a chart. So what are the zeros of the numerator? The zeros of the numerator is -1 and 1. What is the zeros of the denominator? It's just 0. So you see, I put first the numerator, x squared minus 1. Then I put the denominator, which is just simply x. And then at the end, I put the whole expression, x squared minus 1 over x. Now let us look at each of them separately. X squared minus 1 would be 0 if x is -1 or 1. So at these 2 points, it's 0. It is positive, it's negative between the two roots, positive otherwise. This is x squared minus 1. How about x? X just 0 when x is 0 because it's very simple. So positive, negative. Now, when you divide them, you have to be careful. First of all, the whole thing is 0 if x is -1 or 1. So the whole thing would be 0 if x is -1 or 1. But what if x equal to 0? What happens to this fraction? Doesn't work. Does not exist. So we usually put DE for does not exist. So that means this expression does not exist when x equal to 0. Okay, now you just multiply the signs, because once you divide two terms, you just multiply their signs. So plus times plus is plus, negative times plus is negative, negative times negative is positive, positive times negative is negative. So now we are looking for positive solutions or greater than or equal to 0. So that means you're looking for this region and this region. So the solution is basically x greater than or equal to 1 or x greater than or equal to -1 less than 0. So the domain, I can conclude that the domain of f, I write it at the bottom here, the domain of f is the set of all real numbers such that x is greater than -1 less than 0 or x greater than or equal to 1.
X can be 0.
There's no 0 here. I don't include 0. I didn't include 0. So you see, that's the point. So I said x less than 0, greater than -1. It doesn't include 0.
But they don't
Yeah.
X can be 0.
Yeah, in this notation, we exclude basically 0. Because here I wrote does not exist at 0, so I excluded 0. Okay. So this is basically some examples of domain, how to compute the domain. So we discuss square root and like rational functions with denominators. Okay. Now the next topic that I want to discuss is basically polynomials. So what is a So a general form of a polynomial is, so we usually use p of x for polynomials, but you can also use f of x, it doesn't matter. So p of x equal to an x to the power n plus an minus 1 x to the power n minus 1. Don't be scared, because I will tell you, these are just the coefficients for different powers of x, plus a2 x squared plus a1 x plus a0. So each polynomial consists of different powers of x and a combination of them. So you see, like constant function, or right, I'm going to write. So here are the different powers of x, like 1, which is x to the power 0, right? And then x squared, x cubed, x to the power 4, x to the power n. So if you, here are the different powers of x, including 0 powers, which is just 1. Now, if you can combine them together with any coefficients that you want to build a polynomial. So for example, so these are basically the building blocks of a polynomial. So for example, I choose 1x or 2x plus 5x squared. So I combine different powers of x with different coefficients. So these 2 and 5 are called the coefficients of this polynomial, because these are the coefficients of x and x squared. Now, can you, each of you, tell me one example of a polynomial? There are infinitely many examples. You can do whatever you want. You just combine these terms with any powers, but the powers are positive. You have to be careful. You cannot have x to the power -2. So Maggie, tell me one polynomial. Just give an example. This is Maggie's polynomial.
3x cubed
3x cubed plus
7x squared.
7x squared. You can stop here, but you can add more terms if you want. Okay? You, Angel, just 7x
100.
to the power 100, yeah? Okay?
Plus 2x. Can I have like 2x5, x to the power 5, and then 5?
It's good. You don't never, none of you use negative numbers. Okay.
Plus 5x to the power 10.
Let's say minus 5x to the power 10. So the coefficients could be negative. Like here you can have negative, but the exponents, the powers must be positive. You, Michelle. Just give me one polynomial. Plus 6. You, Alex.
3x squared plus 6x.
So you see, you can combine these different exponents with any coefficients that you want. So the only thing is that you cannot have negative exponents. Okay. Now let me recall some important algebraic identities. Some identities that you have seen in grade 10, 11. So the first thing is like x plus a squared is x squared plus 2ax plus a squared. X minus, I mean, when I say plus a, it also includes basically minus a, because if a is negative, then automatically you have 2ax, right? So I don't write x minus a. And then you have x plus a cubed. This is equal to x cubed plus 3ax squared plus 3a squared x plus a cubed. And so on. So in particular, if a is 1, you get like x plus 1 squared is x squared plus 2x plus 1, and x plus 1 cubed is x cubed plus 3x squared plus 3x plus 1. So now another important identity is like what is x squared minus a squared? X squared minus a squared is x minus a times x plus a. X cubed minus a cubed is x minus a times x squared plus ax plus a squared. Again, if you have, in particular, when a is equal to 1, you get x squared minus 1 is just x minus 1 times x plus 1. And x cubed minus 1 is just x minus 1 times x squared plus x plus 1. Now, can you compute x plus like x plus, for example, 2 to the power 4 to the power 5? Do you know the formula for that? Do you know? X to the, for example, x plus 1 to the power 5. Do you know? Pascal triangle, yes, exactly. It comes from that. The name for that formula is Newton binomial formula. So let me tell you, this is good for your also general knowledge. So basically, we want to compute x plus a to any power, like n. This is equal to x to the power n plus n choose 1. You remember n choose 1? Combinations, like n factorial, I will tell you, don't worry. N choose 1 times x to the power n minus 1 times a plus n choose 2 x to the power n minus 2 a squared, and so on. You continue this until you get to n choose n minus 1 times x a to the power n minus 1 plus the last term is a to the power n. And recall that so n choose k in general is n factorial divided by k factorial times n minus k factorial. A factorial means you multiply all numbers from 1 to n. So for example, like n factorial is basically n times n minus 1 times, you multiply all the numbers all to. So for instance, 2 factorial is just 2 times 1 is 2. 3 factorial is 3 times 2 times 1 is 6. Okay. So let me give an example. For example, let's see what is x plus a. X plus a to the power 4. This is x to the power 4 plus 4 choose 1 times x to the power 3 times a plus 4 choose 2 times x squared a squared plus 4 choose 3 times x a cubed plus 4 choose 4 is just 1 times a to the power 4. Now, what is 4 choose 1? Can someone tell me? So remember the formula on the top with purple. N choose k is n factorial divided by k factorial n minus k factorial.
Like 4 times 3 times 2 times 1.
That is 4 factorial, but you have to divide it by 1 factorial times 3 factorial. So let me write it here. So 4 choose 1 is 4 factorial divided by 1 factorial times 3 factorial. But you see 1 factorial is 1, but 4 factorial divided by 3 factorial is just 4. Because when you divide 4 factorial by 3 factorial, you get just 4, right? This is 4 choose 1. How about 4 choose 2? 4 choose 2 is 4 factorial divided by 2 factorial times 2 factorial. So 4 factorial divided by 2 factorial is just 4 times 3, and now divided by 2. So this is 6. And 4 choose 3, you can easily see that it's again 4 factorial divided by 3 factorial times 1 factorial, again 4. Right? So now go back to this formula. So that means we conclude that x plus a to the power 4 is x to the power 4 plus 4 ax to the power 3 plus 6 a squared x to the power 2 plus 4 a cubed x plus a to the power 4. In particular, if a is 1 again, then you get x plus 1 to the power 4 is x to the power 4 plus 4x cubed plus 6x squared plus 4x plus 1. So these numbers 1, 4, 6, 4, 1 are the numbers that appear in the Pascal triangle. Okay, so again, the general formula for x plus a to the power n, I write this formula again using sum notation, summation. I will tell you what I mean by this notation. This is equal to the sum of k or sigma. This is another Greek letter, sigma, capital sigma. You should know that. So in math, you use this letter, capital sigma, if you want to use for summation. If you want to add some values, you use this symbol. It's capital sigma, k from 0 to n of n choose k times x to the power n minus k, a to the power k. Just copy this for now, just copy. Gradually you will learn it, don't worry. I will explain it to you. Okay. So now let's try to compute this together. So you remember the formula? So in this formula, if a is equal to 1, let me write also in the case a equal to 1. No, this is advanced function. Don't worry. Okay, so if a equal to 1 in this formula, then you get x plus 1 to the power n is the sum of k from 0 to n choose k, x to the power n minus k. Because a is just 1, so all powers are 1 are just 1, right? So x plus 1 to the power 6. Now let's do that. X plus 1 to the power 6 is, if k equal, in this formula, look at that formula on the top. So just look at that formula. I'm going to tell you how we can use this formula. If k equals, so first of all, here n equal to 6, right? here n equal to 6. So you have this formula. I just copy this formula, k from 0 to 6, because n is 6, and then 6 choose k, x to the power 6 minus k, right? Since n is equal to k, I just copy the same formula with n equal to 6. Okay, so n is just equal to 6. Now let me tell you how to use this formula. So if k is equal to 0, what is 6 choose 0? So anything choose 0 is 1. So when k equal to 0, you get 1 times x to the power 6 minus 0. So you get x to the power 6. So this is when k equal to 0. So this term corresponds to k equal to 0. Now, if k is equal to 1, you have. So 6 choose 0 is 1. So anything n choose 0 is 1. So now you have when k is equal to 1, if k equal to 1, so you have 6 choose 1. What is 6 choose 1? Is 6. So you have 6 times. Now you have x to the power 6 minus 1, 5. You see, you compute that term inside the sigma symbol for each k, and then you add them together. That's the logic. Clear? Okay, now the next term, can you tell me the next term? You have 6 choose 2, it's 15. Now you have x to the power 6 minus 2, 4. I give it as an exercise to compute next terms. You have how many terms? Other terms, you have to compute the coefficient of x to the 3, x squared, x, and then 1. You have 4 more terms. So this corresponds to k equal to 1. This guy corresponds to k equal to 2, and so on.
Up to 6, right?
Yeah, up to k equal to 6. I can tell what is the term for k equal to 6. That's easy. It's just 1. So the last term is 1, because you have x to the power 0.
So this top number, the n here, that means k is 0 to that number, right?
Yeah, so you count, basically, that's sigma means you count from k equal to 0 to k equal to whatever, like 6.
Okay.
And this sigma means you add all the terms.
So where'd you get x to the power of 6 the first time?
Because I told you that 6 times choose 0 is 1. In general, anything choose 0 is 1.
But why is 1 x to the power of 6? Because 6 minus q, so that's the term.
6 minus 0 is 6, right?
That's the, so you put this term in with that first, right?
So you put
This is
k.
the 0 term. This is the first term, the second, third, fourth.
Is this process clear?
Yeah.
Yeah? How about you, Alex? So your name? Diana? Okay, guys, so we are going to have lunch. And then please come back by 1. Yes. You worked so hard. You did. You didn't. You're just looking at your cell phone. We did the questions. Everything?
No, not yet.
Mostly. So I ask you to come to the whiteboard and do it. Okay.
That was the part.
Where would you remember number?
Yes, I do. Yes.因为上午没有，它是11点开始。下午1点。对。但是他们有讲他是到5点，那他是10点这个是混一起的，然后他是每次就是11点先讲，然后到12点，我们就晚1小时，但是我不想迟到那种，然后就10点就来了。下午也给1个人。你家离得近啊？我家10分钟。哦，那你确实比较。你写完了吗？那个 Excel 昨天写完了。那改了吗？我就今天一直在等他没改。他改了，那你给多少？我也想知道啊。我也很好奇。
Oh, that is.